another day, another question. This one's from the Cambridge exam board. Let's see how it is. In part A of this question, we're asked to show that this trigonometric equation can be rearranged to be put into this form here, involving all these k's and sine x's. In part B, we'll be asked to solve something where the value of k is given. So, a few ways you could do this. I think what I'm going to do is I'm going to times up by the denominator. If I do that, I'm going to get tan of x plus cos of x is equal to k tan of x minus k cos of x. The answer only has sines in, so we're going to need to get rid of these tan some way. Let's turn them into sine over cos. So sine over cos here, and then sine over cos here. We've still got a few cos's around. Where are they going to go? Why don't we times everything by cos? If I times this by cos, the cos will cancel. If I times this by cos, I'll get cos squared. Similarly, if I times this by cos, the cos here will cancel. And if I times this last term by cos, we'll get cos squared. Now we're thinking there's some cos squareds. We don't really want them. So how are we going to get rid of them? This is where your second identity comes in really handy. Sine squared plus cos squared equals 1. So cos squared is 1 minus sine squared. So if I rewrite this out, this is 1 minus sine squared here. K sine x hasn't changed, but we've got now minus k lots of cos squared, which is 1 minus sine squared. Like this. Now it's just sines galore, so we're quite happy. It's just a case of putting it in the form that they want. So let's see how to do that. Let's expand this bracket at the end. Minus k, and then it's going to be plus because it's two negatives in a row. Like this. And this side seems like the positive side. So I'm going to add sine squared. So I've added these together. We've got k sine x, and this time I'm going to minus 1 sine x, like this. Minus k is already on that side, and I'm going to minus 1 from here and here, and that should be equal to 0. Moved everything from here over here. Not quite how it's written, so let's rewrite it in the way it's written. Factorize out the k plus 1 like this, and then the k minus 1 like this, and then the k plus 1 at the end, just to put it in the form that they really want it, just to say, I've done exactly what you wanted, please give me 4 marks in this case. So we're getting 4 marks for that, and we're going to get another 4 marks if we can now solve the equation tan x plus cos x over tan x minus cos x is equal to 4. Use part A. We did not do it for nothing. So that is exactly the same thing as what was in our question, but k is now equal to 4 here. So this comes into this. So what we can say for part B is if originally this is true, then the next line of working will be this line, but with k equals 4. So k plus 1 is 4 plus 1, which is 5. And then k minus 1 is 4 minus 1, which is 3. And then similarly at the end, back to k plus 1, which should be 5. Oh, don't really need a bracket there. Like this. So we're going to get something that doesn't work. Scrap that. Let's use the quadratic formula. In the end, we get this 0.74403.06509. Or, if you'd prefer, this value minus 1.344030651. I actually do prefer that second one because that has no solution, so it means we don't have to do anything with it. The sine graph only goes up to 1 and down to minus 1. So that value is too small. It's too negative. There's not going to be any solutions. So as usual with these, we're going to find the principal value first from the calculator. That's going to be the sine inverse of that value there. I'm going to use all the decimals, or I'm going to use the saved value in the calculator. There's no point rounding here because your final answer will be not as accurate. And I get 48.07590661. That's the principal value. As usual, cast diagram if you want. I'm going to use the symmetries of sine this time. The symmetries of sine tell us that the other solution, if one solution is here, the other solution is here, 180 minus. So 180 minus that answer, and we get 131.9 approximately. Because our range is only 0 to 360, as it says up here, there's only going to be those two solutions. There's going to be no more solutions at all. So final answer, squeeze it at the bottom here, 48. Just looking back to the question, it doesn't mention rounding it or anything, so I'm just going to do 3 significant figures to be safe. So 48.1 or 132 degrees for another 4 marks. 8 marks in total, which I think is actually not too bad. Whether you have another trig question complete, if there are any points that you aren't super confident on, please leave a comment down below.